All right, we are going to be counting again, counting the number of ways things can happen, but this time we're going to talk about the number of combinations. And combinations is what happens when we talk about selecting objects without regard to order arrangement. So permutations are with orders. Combinations are simply groups. Now if we look at teams of 3, selected from A, B, C, D, and E. We could have A, B, C. We could have A, B, D. We could have A, B, E. We could have B, A, C. We could have B, C, D. We could have B, DE, we could have all these different ways. And one thing that I want to point out here is I'm not going to list all these out, but BAC and ABC are two different orders. They're different permutations. However, they are the same group of 3 people. So when we talk about combinations, we talk about these 2 groups as being the same. And there's going to be a lot of different repeated groups when we write out all the orders. The way that we deal with combinations relates to permutations. There's the formula for permutations, n factorial over n minus r factorial. But because we have all these things being counted more than once, we have to divide by how many times those will be repeated, which is r factorial. And we're not going to get into really the proof of this. The different notations for combinations are shown here. And we saw these numbers with Pascal's triangle when we dealt with the binomial expansion. So let's do some examples. And we're going to have our calculators handy. How many different teams of 3 can be selected from a squad of 8? So this is a group. Each person within the team doesn't have a specific role. So the notation that we're going to do is 8C3. Or like this. Or like this. And doing it by hand, 8 factorial over 3 factorial, 8 minus 3 factorial. We can use our skills with factorials to do some simplifying. 3 times 2 times 1 is 6. This is 56. Or, we've got these handy-dandy graphing calculators. Let's use them. Let's refresh on where this is. We're going to go Menu, Statistics. That's not what I wanted to do. Menu, Probability, and we want combinations. There's that factorial. We're going to go combinations, NCR. We want 8, 3. There's our 56. If you want to do these out longhand, you can. But you don't have to for intents and purposes in this course. Now, part B is a little different. The team must include the captain. So now there's 2 spots that we have to fill. There's the captain role and then the rest. So how many captains are there going to be? Well, that's going to be 1 choose 1. I'm sorry, not 1 choose 1, 8 choose 1. We have to pick one of the 8 people. And then how many people are left to choose from for the rest? Well, we picked 1 person, so there's 7 total. And of those 7, we want to know how many ways can we group them into 2. 8 choose 1 times 7 choose 2. Eight choose 1 times 7 choose 2. There are 168 different teams we can make with that configuration. This is no different than the simple counting we are doing where we have 2 choices to make. We have to choose a captain, and then we have to choose the rest. So now we're talking about an equestrian team, horse riders, jumping over fences, through rings of fire, that sort of thing. So team of 4, chosen from 7 male and 6 female. How many different teams can be chosen if there are no restrictions? So it doesn't matter how many males and how many females. For part A, how many riders do we have total? There are 13. And of those 13, we want to know how many groups of 4 we can make. So 13 choose 4. That's part A. For part B, there must be 2 of each sex. So in other words, we need 2 male and 2 female. So how many ways are there of getting 2 males? Well, there's 7 choose 2. And means multiply. How many females are there? 6, and we want to choose 2 of them again. So we would multiply these 2 combinations together, giving us our total amount. Lastly, at least 1 of each sex. That means that we could have 1 male and 3 females. Or, what does or mean, guys? Or means add 2 male and 2 female. Or 3 male and 1 female. So we're going to have 3 of these kind of things that we're going to add together. Forgot the word or. So what we're looking at is 7 choose 1 times 6 choose 3 plus 7 choose 2 times 6 choose 2 plus 7 choose 3, that's the number of ways of picking 3 males, times the number of ways of picking 1 female, and we put that all in the calculator, and we will get one nice numerical answer. You have to think of these things as different events, just like we did with our regular counting that we were doing way early on, tree diagrams, basic addition and multiplication properties. So no different, except now we're putting them into groups. We're taking part of the whole, part of the entire group, and putting them into smaller groups, and that's where this notion of combinations comes in. And remember, for all these calculations, I am completely okay and fully expecting that you will use your calculator to do that.